use or underground service entrance, cables are restricted from indoor use because they lack inherent flame retardant properties. This restriction is explicitly stated in the National Electrical Code, specifically Article 338.10 BONIB, which says that use cables shall not be used where exposed within buildings. Furthermore, the NFPA 70E, which is the standard for electrical safety in the workplace, in Section 130.3, DONA prohibits the use of use cables inside buildings. The reasoning of the electrical safety inspectors is technically correct, that use cables cannot be used to enter the building even if the distance is minimal. The NEC requires the service disconnecting means to be located either outside the building or as close as possible to the point of entrance inside the building. This limitation is intended to minimize the potential for fire within the building in the event of a short circuit or other electrical fault. To address the issue of use cable being used to supply the service main inside a building, consider the following alternative solutions. Firstly, extend the service conductors to the meter outside the building. This involves moving the meter socket outside the building and running the service conductors directly to it. For this portion, it's important to use a flame retardant conductor type such as THWN or XHHW. Secondly, install service entrance enclosure outside the building. This involves routing the use cable into the service entrance enclosure and terminating it on the line side of the disconnect switch. From the service entrance enclosure, run flame retardant conductors to the main inside the building. Thirdly, use a splicing enclosure, also known as outside the building to connect the use cable to flame retardant conductors that enter the building. When using a splicing enclosure, ensure it is rated for the appropriate environmental conditions. Adhering to the code requirements is essential for ensuring the safety of the building and its occupants. Use cables are not suitable for indoor use and should not be used to supply the service main in the building. Therefore, while relocating the meter or installing additional components might seem inconvenient, it is crucial to comply with the code requirements for electrical safety. It's important to note that the NEC and NFPA 70E are updated regularly, so always refer to the latest editions for the most accurate and up-to-date information. The specific articles and sections mentioned, such as 338.10 BONIB and 130.3 DONIB, are key references for understanding the restrictions on use cable and the requirements for electrical installations. When selecting alternative conductors such as THWN or XHHW, ensure that they are appropriately sized for the intended load and that they are installed in accordance with all applicable code requirements. This includes proper support, protection from physical damage, and correct termination methods. The service entrance enclosure should be selected based on the specific requirements of the installation, including the size of the service conductors, the available space, and the environmental conditions. It should be listed and labeled for use as service equipment and installed in accordance with the manufacturer's instructions. The splicing enclosure, or should be rated for the environment in which it is installed, such as wet or dry locations. It should be listed and labeled for use with the specific types of conductors being spliced and installed in accordance with the manufacturer's instructions. In addition to the NEC and NFPA 70E, local codes and regulations may also apply to electrical installations. It's essential to check with the local authorities having jurisdiction, OJ, to ensure compliance with all applicable requirements. Proper grounding and bonding are also crucial for electrical safety. Ensure that the service equipment, including the meter socket, service entrance enclosure, and splicing enclosure, are properly grounded and bonded in accordance with the NEC. This helps to minimize the risk of electrical shock and equipment damage. Regular inspections and maintenance are essential for ensuring the continued safety and reliability of electrical systems. Schedule periodic inspections by qualified electricians to identify and address any potential problems before they become safety hazards. When making any electrical modifications or repairs, always disconnect the power supply and follow safe work practices. Use appropriate personal protective equipment (PPE), such as insulated gloves and eye protection, to minimize the risk of electrical shock or injury. If you are not qualified to perform electrical work, hire a licensed electrician to do the job. Working with electricity can be dangerous, and it's important to have the knowledge and skills necessary to do the work safely. In summary, use cable is not permitted for indoor use due to its lack of flame retardant properties. The NEC and NFPA 70 explicitly prohibit its use inside buildings. To address this issue, consider alternative solutions such as extending the service conductors to the meter outside the building, installing a service entrance enclosure, or using a splicing enclosure. When selecting and installing electrical equipment, always follow the manufacturer's instructions and comply with all applicable codes and regulations. Prioritize electrical safety to protect the building and its occupants from potential hazards.